you do not have this. You don't have it. For who else does not have the quiz tool paper? You have it? Sure. So let's take a look at this. It's too small. See it? People who sitting on the back can see this, the monitor. So convert the following binary numbers to decimal. I will pick up this tool and show you how to do it. So you probably will know how to do the other ones. So what about this one? Binary to decimal. Did you watch the video? Watch it. So this one represent 2 to the third. So you didn't watch the video, just memorize it. So this digit has 3 trailing binary bits after it. So it's going to be 2 to the third as a binary number. It's not a decimal number. And the second one, the second one is 0. So this is 1 times this. And the second one is 0 times 2, 2 to the second power, because there are 2 bits after this digit. And this one is 1 times 2 to the first plus 1 times 2 to the 0 power. And this equals to 8 plus 0 plus 2 plus 1. So that will be 11. Okay. And this one. So do the same thing for the integer part. And now let's look at the fractional part here, 0.11. So this digit is 1 times 2 to the minus 1, minus first, plus 1 times 2 to the minus second. So totally, that will be 0.5 plus 0.25. So it's 0.75. Right. If you didn't watch the video or you were not in the class last week, just watch the video. I think it's pretty simple to solve it. Just follow all these procedure to do that. Convert the following decimal numbers to binary. Let's do 10 first. 10 divided by 2, 5. Remainder is 0. And divide by 2 again. Result is 2. Remainder is 1. Divide by 2 again. 1. 0. Divide by 2 again, 0, 1. So that's the result. That's the remainder. And look backwards. So 10 will be 1010. And if you want to verify this really quick, so this is 2 to the third. This is 2 to the first. So add them together is 8 plus 2 is 10. So verify. That's a freshman course. So whatever is helpful for you guys. What about this one? Let's just look at this part. So after this one, we'll have a 5 minutes break. I'll come back. 0.625, that's in decimal and convert it to binary form. So you are multiplying this by 2 every time, or divided by half. Is that right? Yes. So 2 times this will be 1.25. And take 1 out to here and reset it to 0. And then do it again. So 0.25 times 2 will be 0.5. So 0 is still 0. Just put a 0 here. And do this again. 1.0, 1, 0.0, done. So, and look from the top to the bottom. So you are getting 0.101. So that's a binary form for this decimal number. This one, convert to decimal. Do you want me to run this for you? Convert the A-based number to decimal. So 3A, which is 17.28 based, convert it to something but 10 based, which is decimal number. So you know this represent 1 times 8 to the first power plus 7 times 8 to the 0th power plus this one is 2 times 8 to the minus first power. And just add them together, you are getting a 10 based number for this specific 8 based number. It's not hard, just watch the video, you'll get it. Pretty simple. And round it to 2 digits and pass the decimal point. Wait, convert to decimal. Yeah, I don't think there should be hexadecimal point, right? Because it's not hex at all, decimal point. Convert the answer to binary. So let's look at what is this now. So 8 plus 7 plus, so 2 times this will be 0.25. So this is 15.25, I guess. Is that correct? Any of you did this? If I'm correct, I think this should be 8 plus. Yeah, should be right. Convert this one to binary. All right, we did it here. You know how to convert a decimal to binary. Just follow the procedure here, and you should be able to get it. The next, convert to binary for this decimal number. So the way to do that is just convert every hex digit to 4 binary digits. So D is 13. 13 is 8 plus 5. This is 8, and this is 5. So that's D. E is 14, so it's 1110. C is 12, it's 1100. Point A is 10, 1010. So every hex number digit here can be converted into 4 digits of binary numbers. Okay, and these ones are pretty simple, I guess. I have some examples in from last week. Just watch the video so you'll know how to do this. And what are these ones? These ones? We learned 1 and zeros, but we didn't learn A. So A is just a case, right? You can call it B, call it C. So keep in mind, A is not 10 in hex here. So A is just one binary bit, all right? So A, remember the chart? Let me probably do the chart again. So repeating is the best way to learn. let's draw the chart. For the AND logic, 1 0 1 0. Should have a break, right? Let's have a break. 5 minutes break. We'll come back. Let's come back at 42 on your smartphone. This is a required policy from the college. Can you just show me real quick? Yep. Okay. So,
yeah.
Did you?
No, it really doesn't work. Like, I don't know why mine is the only one I found that doesn't work, and I have to re-click on this every time and it shows someone. I know. So you can imagine how stiff that is.
So try to have the lines just kind of careful because you have.
Yeah, I mean, I play it this way. I don't know.
All right. Thank you for your cooperation. Stay safe. It's more important than anything else. Okay, so let's take a look. In this crap table I just drew, I'm really bad at drawing. So anyway, so you know what's going on here. It's an AND logic. So 1 and 1 will be what? And 1 and 1 is 1. So think about the story I told you, right? So if you have two good players, you're the coach, so you can pick up both Kobe Bryant and LeBron James. So 1 and 1 will win the game, right? So both Kobe and LeBron. So you'll win. So win. 1 is win. So this player sucks, right? So this player helps other team to win. And you have this guy has to stay on the court because it's AND logic. So this guy and Kobe, so Kobe cannot help anymore because this guy just like keep shooting to his own basket. So you'll lose a game, right? So 0 and 1, same. You still got this bad player who helps other team to win. So 0, 0 and 0. The poor coach, right? It's no choice. So what about OR logic? 1 0 1 0. Frozen. A good one or a good one, two good choices will win. A good one or a bad one, you have a choice. Just do not pick up the bad one. Pick up the good one. So OR logic. A good one or a bad one, definitely win. A bad one or a good one, win. A bad one or a bad one, lose. Okay. So let's pick up the case A instead of 1 or zeros. So let's do this. A naught, 1 0. This table. A naught, 1 0. Okay, getting more challenging. What are they? A or A? No, let's or. Let's do or first. I'm getting one chocolate or one chocolate. So what I'm getting, one chocolate. It can be a good chocolate, can be a bad chocolate, doesn't matter. It's going to be that chocolate. A or A bar, A or A not. A or A not. Think about it. So if you do not, if you don't know the answer immediately, I will suggest you just give some examples. If A is 1, if A is 1, so 1 or 1 not, which is 0, is 1. You have a good choice. Do not pick up this guy. 1. If A is 0, right? So 0 or 1, still 1. So A or A not is what? Come on. Do you have A here? A is changing. You have 1 or 0 for A, but you are always getting 1. So what is the result? 1. Because A can be 1 or 0, right? I just give examples here. Like if A is 1, then A not will be 0. So 1 or 0 is 1. If A is 0, then A not will be 1. 0 or 1 is still 1. So it's always 1. So no matter what A is, A or A not will be 1. So the way to think about this is for the OR logic, okay? Think about that. Logan, did I pronounce this correctly? Logan. So Logan or not Logan. So the world, universe, except for himself. So he or anything outside of him. So that's pretty much everything. Did I cover everything? You or not you. That's everything, right? So that's 1. That's a universe. What about A or 1? Yeah, 1, because you don't need to care about A. You always get a good player. Just pick up the good player. You'll win the game. A or 0. A or 0. Depends on A, because 0 is the bad player. You are trying to pick up, so here's a player you don't even know. You don't know if he can play good or not. But there is definitely a bad one, right? So get rid of the bad one, but just look at A. So what's the result? The result really depends on A. So what is the result here? A. If A is 1, you'll win. If A is 0, you'll lose. A not or A, same. 1. A not or A not, A not. A not or 1, 1. You have a good one, just pick up good one. A not or 0, A not. 1 or A, 1. 1 or everything will be 1. 0 or everything will be no 0, a bad one, or anything can be 1, 0, can be anything, can be A not, right? So 0, a bad player, or you have two choices. You're the coach, right? You have two choices: a bad one or anything. You just pick up anything, you get some chances to get a good one, right? Okay. So what's the result? Whatever in anything. It's a 0. It's not worse than that one because it's equivalent. If you get a chance, get a 1, you win. So you don't even need to look at it, right? Just copy everything here. A not, 1, 0. Okay? Next, the AND logic. So if you take my logic 241, you understand why we are using 0 and 1s in computers, because these are backed up by every single transistor in the circuit. So they are doing this logic operation for you. And that's how the computer works. So that's the OR logic. What about AND? A and D, 1, 0, A naught, 1, 0, A naught. Okay, and 1 and 1, 1 and 0, 0, because this bad player is on the court, because it's AND logic, they have to be on the court at the same time, so you'll lose. 1 and A, depends on A, so just A. 1 and A bar, A naught, right? So 0 and everything will be, God, this guy. Keep away from this guy. It's killing everything. A and everything, you don't know. No. A and everything. It depends. If you got a 1, if you got a 0, right? So A and 1, A depends on A because 1 is good. A, you don't know. So A and 1 is A. A and 0, 0 and everything will be 0. So let's just finish this column first. So A, 0 and everything is 0, right? Right? 0 and everything is 0. Same as here, 0 and everything 0. Okay? A and A. A and A bar. Think about it. A and A bar. So A, there are only two cases in binary, 1 or 0, right? So A, doesn't matter what is A. A and A bar, there must be a 0 in there. Is that correct? Okay. So it's an AND logic. So what's going to happen? You'll lose a game since there always will be a 0 in this operation. So A and A bar will be. So A or A bar will be A or A bar, myself or not myself. It's the universe, it's everything. So it's 1. A bar and 1. A bar and 1. A bar. A bar and A. We did it, right? So A bar and A bar is a 0. Because there'll always be a 0 in there. A bar and A bar. A bar. A bar and A bar, just A bar. Or A naught. Right? So if you note that, these two tables, these will be trivial. What is this? A and A. A and 0. No, A and A is A. A and 0. A and 1. A. A and A naught. A and A or A. A or 0. A or 1. A or A naught. 1. Let's do this. A and A is A, and A is A, and A is still A. Wasting your time. A and 1 is A. A and 0 is 0. 0 and B is 0. So whenever you see a 0 in the AND operation, everything will be killed. It's going to be 0 eventually. A or A is A. A and A is A. A or A is still A. A or 1 is 1. If you have a 1 in the OR operation, it's going to be 1 because you have a choice and you have a good player here. It's OR logic. Doesn't matter other things. If you see a 1 in OR logic, it's going to be 1. A and A or A or A. 1 or 1, 1. A naught or A, 1. Me, myself or not myself, right? 1. Or you got a 1 in OR logic, so it's going to be 1 eventually. It's going to be 1. 1 and A, 1 and A. 1 and A depends on A. If A is 0, then it's going to be 0. So that's the unlogic. Doesn't matter. So unlogic can be, so A, this is A and B. So A and B, there are, for A and B, there are several formats for this to represent this. There are several different symbols. It can be a little dot in the middle, or it can be this. Or you don't need to put anything in the middle. So just AB. That means A and B. So like this one, there's nothing in the middle here. So you know it's an unlogic. And you know 0 is in unlogic. So everything will be killed by the 0. So the result will be 0. 1 or 0, you have a choice, right? You'll win. Done. All right, let's take a look at the tutorial for the car. Okay, so that's the easy part. Relax. Where are snacks? Relax, relax. Okay. So you know the link for the course, right? If you are trying to watch the video, just go to this link and you'll see the schedule, and we are here now. So I'm supposed to cover the tutorial here. Let's try to do the best. We still have, I think, 25 minutes. And you have 2 hours for each, totally 6 hours to assemble the car. And I don't think it's reasonable, or we have a time to let you design a PCB, which stands for printed circuit board. It's actually this one. So if you look at tutorial part 2, so here's a schematic. You are going to design the schematic in the Ego PCB and convert it into a circuit layout, and send it to PCBWay, which is a company overseas for fabrication. It's $5 for 10 pieces, so you can get 10 copies, and you actually just need to assemble one. But we don't have time to get a PCB done. So the tutor here, I think her name is Cheyenne. I think she has designed a functioning PCB. And if we check, yeah, I just sent it for fabrication a couple days ago, and it takes about 4 days to be shipped, to arrive here. Delivery, oh, it's already here. So just takes DHL. Oh, it's in Denver now. See? Arrived at Denver today. So probably I'll get it tomorrow. And I ordered 20 something pieces. So I'll give you one. And after you are done with your circuit connection on the breadboard, which is not this one, but with the jumping wires, you'll see here. Oh, this one. So that's not a PCB. It's called breadboard. Bread. You eat bread in the morning. Bread. I don't know why it's called breadboard, but it's a breadboard. So it has all the holes you can plug in to make the electrical connections, and with all the chips plug into the board and the power supply. and these are the infrared sensors, can sense the line on the table, so you can follow the line. So here's the design procedure for a circuit. This is a really simple circuit, but I'm trying to let you know this is an intro level course, right, for circuit design. So I just want to let you know what's the standard procedure to design a circuit for application. So you design the circuit schematic, and you assemble everything on a breadboard, and you test it. Okay, after you know it's going to work, you convert everything into a PCB, a printed circuit board. So you have PCBs everywhere. So the motherboard in your desktop, in your smartphone, everywhere there are PCBs. The copper traces are being printed on the board. They can integrate more circuits in a smaller area. Okay, and also less errors. If you can imagine, so all the wires are being plugged into the board. It's really easily like some of them will pop up from the hole, and you'll lose the connection. So every time you developed the circuit and assembled everything on the breadboard, you want to convert it into PCB as soon as you can. The cost is pretty low, and will guarantee you it's going to work. Otherwise, you have to debug this one pretty often. You can lose a wire, you can miss a connection somewhere if somebody touch it. So you have to restart working on everything again to debug it. A lot of pain. So after you are done here, just convert it into a PCB. That's normally what I do. So I think I showed you the result. So here's the goal. Here's a video he used a breadboard to test the functionality of the circuit, and it's been working. And later, so she converted everything to a PCB, which is in this tutorial. And I'm not expecting you guys to do a PCB, even though like she's really good. She just make a tutorial, very thorough tutorial for you. You just need to follow if you really want to make a PCB. If you decide to get a PCB for yourself, I can pay for you for the fabrication. You need to let me know earlier. But it's not required for this class. So she shows you every single step to draw the schematic and the layout for the board if you want to follow. However, it's not required. I will, since this board is in Denver now, and I'm pretty sure I will receive it this week or next week. So you will have I will give you one of her board to you, so you can practice on soldering the parts to the board and demonstrate it. Because the circuit is the same. There's no difference if you assemble everything to a breadboard and the circuit on the PCB. There's no difference. So if you do, I think we don't have time to get a PCB done. So I think it's good to let you practice on soldering. All the surface mount components are tiny, like a piece of rice or even smaller. Solder every single part to the PCB and test it. It's gonna be a really good experience, and you can own that PCB after it's done. It's free. I won't charge you. You can take it home, trophy. Okay, let's look at the circuit, see if you can understand what's going on. I know you are tired. I'm tired too. You are passively receiving message, but I have been talking like this for 4 hours today. My brain is really actually working really well now. Okay. First, you need a driver for the motor. You have two DC motors on the two sides of the car. Not full motor, not four wheels, two wheels, right? So two wheels on the two sides. And you need a driver to drive it. The reason is the digital logic is a low power pin. Probably don't understand now, but we just need to make the connections for now. And I will explain this to you as good as I can. Okay. So these two pins, so this is the motor, this is another motor, it's a DC motor. So the DC motor is pretty easy to use. the motor has two terminals, has two pins, metal pins, and you apply a voltage to the two pins, it's going to start rotating. That's it. Okay. However, the motor has a low input resistance. Doesn't matter if you don't know what's that, which means it's like a low resistor, pretty small resistor. It's normally 50 ohms. If you apply 5 volts to the motor, and it's going to give you a lot of current because 50 ohms is a low resistance, but it's a heavy load. Whenever we are talking about heavy load, it's because that component is drawing a lot of current from the source. So that's why it's heavy. So a small resistor will be a heavy load for the circuit because just use Ohm's law, voltage over resistor will give you a high current. So the motor is a heavy load, and you have two motors on the two sides, and you do need a driver to drive it because only the driver can provide sufficient amount of current to let it run. And there are other connections as well. Let's take a look at the circuit. This is she just drew all these pictures to show you how to assemble the car. And just mechanically how to assemble it. So that's a circuit connection. So these are the so this is a motor driver, which can drive two motors. So M means motor, so two motors on the two sides. And this is a amplifier, will receive the signal and give an output to the driver, like commands to let it know where or how fast it is willing to rotate the motor. So let's take a look at the circuit. Like, why do we need an amplifier for this? Oh, she didn't draw it. So let's go to the part 2. So you'll see the schematic here. All right, this one. That's the main circuit for the car. I know there are a lot of questions, right? So what is that triangle? So the triangle, the name of this device is just a symbol for that device. Okay? So that device is called LM393. It's an amplifier. So the amplifier, you don't need to know how to use it now. It's a 300 level class you probably will take in the future, in junior year, senior year even. We just need to know how to use it. So first, you need to power it up. It has two pins, one for ground, one for V in, which is a 5 volts power from the battery. And there's the output. And there are two inputs. So the main thing happens at the two inputs. So let's take a look at here. This amplifier is being used as a comparator. Okay. Comparator is comparing these two pins, and if the plus pin is higher than the minus pin in terms of voltage, it will give a 5 volts or the power supply's voltage, whatever it is, can be 6 volts, as the output. That's the first mode. And the second mode, whenever this is lower than the minus, it's going to give you a 0. That's it. You know, I know this is hard to understand, but you just need to know the two modes. So this device only operates at the two modes. So the output, there are only two types of output for this device. The voltage, the power supply's voltage, or 0. Okay, so if the voltage here is higher than here, you'll get V in's voltage, which is high. If this is lower than this, you'll get a low, which is 0. That's it. It's a comparator. It's comparing these two inputs. Doesn't matter what are they, but it's comparing these two pins. If the plus pin is higher than the minus pin, you're getting a voltage high. If the plus pin is lower than the minus pin, you're getting a voltage low, which is 0 volts. Okay, that's it. So you can use the output to turn on and turn off the motor. Okay, voltage high will turn it on, voltage low will turn it off. And now the sensor. So the IR sensor has an emitter and a receiver. This module directly use it. Okay, so one is emitter, one is receiver. The emitter is going to emit an invisible light, infrared light you couldn't see. So like, for example, emitter, receiver, okay? And it's going to emit IR light to that direction. So the receiver cannot receive it because it's not receiving it. It's shooting to there, the front, shooting forward. If you have something in the front, it's going to reflect that IR light and reflect, so the receiver will receive it. But that object has to be a light color. The table surface here is considered as a light color, but the table surface over there is black. It is not able to reflect the IR light. It's going to absorb it. So if I have a line on the table which is black, so the sensor can tell if the sensor is on the above the line or above the table surface. Because above the table surface, there will be a reflected IR light being received by the receiver. But whenever it's above the black tape, which is the line, because this is following the black line here, whenever the sensor is above the black line, the IR light will be absorbed by the line, and there's no signal being received or being reflected by the receiver. Okay, so there's a signal telling you if the car is on track or not. Is that making sense? I know you guys are tired. But whenever you assemble the car and it start following a line, it will be really fun. It's a really satisfying moment. So I think we can, since apparently I can tell nobody's listening to me right now. You guys are doing anything else, which is fine. I understand that. But let's cover more about the circuit theory. So it's pretty simple because we are just trying to build this. I'm pretty sure you guys can get it done in 1 or 2 sessions. So the very last one will be presentation probably. What about that? Or if you want to spend more time on PCB design, you can come over. So we have Eco PCB software in the desktops. You can do it over here. So in the past, in circuit 1, this project is actually a final course project. The students have to assemble all the parts on this module to the breadboard. But however, here I just purchased all the modules for you. You don't have to assemble anything on the module. Directly use the module plugin and just put these 2 parts and part it up. It should start working. So I think it's easier to start having fun for you guys. I think you will like it. If you have to assemble, including the amplifiers and everything to the board, you will have a lot of voltage nodes or parts to debug, and there might be a lot of problems. I have to debug every single circuit for every one of you, and that's not a good life for me. I won't enjoy that, but I will help you. If you really need me to debug your circuit, I can do that easily. I have done this for 10 years for all the other students as well. So that's the goal for this class, not the PCB. So this is the goal. If you get this done, you start following the line, you got full credit for this course. Okay. Let's call it today, and we'll see you next week.